I'm very pleased to be here at the NoCOUG 2020 virtual summer conference, doing the Ready, Set, Go Oracle Database Server on AWS EC2 in 30 minutes talk. FlashGrid makes innovative software solutions for Oracle database infrastructures on public clouds and in the data center. And today, I will speak about the new way to establish an Oracle database server on AWS EC2 using our SkyBase product. With the approaches that we suggest, you can launch a customized Oracle database in 30 minutes in a robust and repeatable way with a guaranteed results. And my co-host today is Art Danielov, CTO and CEO of FlashGrid. Art will be answering the more technical questions that you may have, and also will do the technical presentation at the end of this talk. Before we dive deep into what SkyBase has to offer, let us stop for a moment to review what options are there to deploy an Oracle database on AWS. AWS Relational Database Service, RDS, is obviously the first thing that comes to one's mind. RDS is a managed database service that is doing a great job by offering a one-size-fits-all Oracle database managed by AWS. However, it is obvious that relinquishing a lot of control over an RDS database to AWS for the convenience of simplification comes at a cost. With RDS, you are not in control of the database patching anymore, can't use ASM, multi-tenant databases, and other advanced features. So it is always a bit of a balancing act of how much are you ready to modify your RFP to accommodate your requirements to what RDS can deliver in terms of Oracle database. Now let's go to another extreme. If a managed database service is not flexible to deliver every feature you need, then do-it-yourself approach surely is, or is it? You definitely can provision an AWS instance, attach some EC2 storage to it, install the database, patch and configure it, and be in full control of the database server. I am a DIY person myself and really enjoy the process, but not always the result. Whether a home improvement project or a database setup, quite often you make mistakes in the process. With an enterprise-grade database, the mistakes can be costly and the consequences can range anywhere from sleepless nights studying manuals and fixing errors to actually data loss. So DIY is good when implementation time is not a factor and trial and error approach is okay. But this is seldom the case. And as you will see later, some requirements, as for example, having an Oracle database larger than 100 terabyte on AWS, requires more than throwing an AWS instance and some storage at it. Getting closer to the main theme of today's talk, SkyBase is our proposed way to deploy database systems as infrastructure as code. Why should you limit yourself to a managed database service or wrestle with building a database from a set of infrastructure and software components when you can have a neat CloudFormation script that does everything for you, from provisioning the infrastructure instances and storage to installing and patching the database, and providing you with an architecture that matches your requirements and is guaranteed to work with all the components fitting together and the database working out of the box. Let's go through what SkyBase is. Just like a hardware-engineered system that was delivered to a data center pre-built, pre-tested, and pre-configured, ready to use immediately after connected, SkyBase is an engineered cloud system a virtual appliance that you deploy in your AWS account. It is important to understand that SkyBase is not a managed database service. It is a virtual appliance that is in your hands and under your control from the very beginning. SkyBase can provide storage sizes in excess of 100 terabyte for your Oracle database, and I will later show you how. You can achieve extremely high storage I/O throughput, exceeding 10 gigabytes per second. And if your implementations require custom security hardening, we are working on implementing the Center for Internet Security, CIS, hardening for SkyBase images as an option. After you have deployed your database, how do you make sure its infrastructure works as intended for the lifetime of the system? SkyBase comes with 24/7 customer support worldwide with 30-minute response time to critical issues. And finally, just 30 minutes are required to launch a fully configured and ready-to-use Oracle server on EC2 with SkyBase. Now let's take a look at several SkyBase architectures, starting from the standard one. The standard configuration can use a wide variety of EC2 instances, for example, R4, R5, M4, M5, and many other instance families, up to i3 family, including the i3 Metal instance. The architecture uses general-purpose SSD volumes, and this is actually one of the advantages of the architecture from the cost-performance standpoint. SkyBase allows aggregating multiple general-purpose SSD GP2 volumes in ASM disk groups. As a result, you will get the performance higher than with the provisioned IOPS while paying the lower cost of general-purpose SSDs. The storage performance has been measured to 80,000 IOPS and throughput to 2.2 gigabytes per second. And as I will show later, every parameter of the SkyBase setups can be configured online and then deployed as an infrastructure as code CloudFormation script. And as we are getting into the more technical stuff, please write your questions in the chat, and Art and me will do our best to answer them. Moving to more extreme use cases, here is an implementation architecture when you need extreme storage performance. With this configuration, you can have an order of magnitude higher storage performance than with the standard setup. The architecture is based on i3-EM Metal AWS instance and uses the local NVMe SSD storage to achieve 2 million read IOPS and 16 gigabytes per second of read transfer. If you are already familiar with AWS instances that have local NVMe SSDs, I can expect a question about NVMe SSDs being ephemeral, or in other words, non-persistent. When you turn off the instance, next time you spin it up, the local NVMe disks will not have the data anymore, as they are cleaned by AWS to be reprovisioned. SkyBase addresses this by mirroring the fast but ephemeral NVMe storage to regular persistent EBS GP2 volumes. Even if your i3-EM Metal instance gets recycled, a mirror of your data is safely residing on the EBS storage. With this architecture, you can address needs for very read-intensive implementations. Now let's take a look at what SkyBase has to offer if your primary need is an extra large database, let's say 100 terabytes or more. This configuration can be based on EC2 instances that support 100 gigabit network, because it will rely on separate external storage nodes connected by a network, similar to Exadata storage cells. When you will use 5 C5 18x large storage nodes, you will get an aggregated 10 gigabytes per second of storage throughput and database capacities exceeding 100 terabytes if needed. When engineering the SkyBase XL architecture, we paid special attention to reliability. Indeed, with so many storage nodes and EBS volumes on each storage node, the likelihood of having a failure increases, as does the maintenance time. The way we address this is using mirroring across the storage nodes. In this case, SkyBase is configured with normal redundancy, so that each block has 2 copies on different storage servers. Again, a concept similar to how the Exadata storage works. If a disk on a storage server goes down, or an entire storage server fails, there will always be a second copy of the data on the other storage servers. Here, I'd also like to mention that if you have very strict availability requirements, you should check out our today's SkyCluster presentation for a demo of how you implement Oracle RAC, Real Application Clusters, on AWS. The SkyBase system that you get on AWS is very Oracle DBA friendly. You will still operate in a very familiar environment, Oracle Automated Storage Manager, GI Restart. You can use the standard familiar tools, RMAN, DataGuard, Golden Gate, Oracle Enterprise Manager. You have full control over database features and patching. The patching process is standard. Storage can be easily expanded, and you are backed up by FlashGrid support that has very deep Oracle expertise, and what's also very important, deep AWS expertise. So we bring both together, and we understand very well both the Oracle side of things and AWS side of things. Security is always important, and it starts with you having full control over the database from the moment you deploy it in your AWS account. We never have access to the instances or to the storage. We're not exposed to it, even during the support. Data at rest is encrypted by EBS, and as I mentioned, CIS security hardening is an option that we will be adding very soon. Here is the compatibility list for SkyBase. It's compatible with Oracle database starting from 11.2 and all the way up to 19c. You will need Oracle Linux 7 or Red Hat Linux 7 operating system. The standard tools, it's compatible with standard tools, as I mentioned. EC2 instances, there is a long list of instances that you can use for SkyBase, and in the technical demo that will follow soon, you will see a long list of the families and instances that you can use. And we support both commercial and US government clouds and all the regions worldwide. When it comes to support, SkyBase is covered by 24/7 support by FlashGrid for the entire infrastructure, which means that we are not limiting the support to a particular piece of the system or SkyBase software, for example. We support the infrastructure stack throughout, and we will look into problems with Oracle software, with our software, with AWS instances, with networking, with storage, operating system. You can come to us with a generic performance problem when you're not happy with how the system performs, or you see some deterioration of performance. We can be the single starting point for infrastructure-related issue support. Now we're coming close to our technical demo. As we started the talk with the benefits of infrastructure as code deployments, specifically CloudFormation for AWS, we have the online tool SkyBase Launcher, which is available on our website. You don't need to be registered or or logged in to use it, you can just go to our website and select the SkyBase Launcher for SkyBase for AWS. And there will be an online configurator where you can set the parameters of your database and produce the CloudFormation script, launch it in your account, and in 30 minutes, get your database up and running. And this is the point where I hand it over to Art Danielov, CEO and CTO, FlashGrid, to do the actual demo.
All right, thanks, Emil. Let me just switch over and share my screen. And I'll show you quickly how you can actually create your SkyBase. All right, so I hope everybody can see my screen now. All right, so you can see the browser, right? Okay, so well, first we go to the SkyBase product, SkyBase Oracle on AWS. So, and here at the bottom of this page, there's a launch button. So we'll just click on this, and it takes us to the launcher tool. So again, like Emil said, you don't even have to be registered. You just need to prove that you're a human, not a robot, to use it. And this tool will walk you through a number of steps, which are pretty simple steps. And at the end of the process, it will generate a CloudFormation template for you that you can deploy in your AWS account. So the first step is just we select the region where we want to deploy it. And you see a full list of various regions that are available on AWS and just the time zone. So next is the operating system. Like Emil said, you have a choice of Oracle Linux or Red Hat. And so one item here that you need to do actually is to get subscription through the AWS Marketplace. So our software is delivered through an image that is delivered through AWS Marketplace. So there are two hyperlinks here, depending on your choice of the OS. You actually need to subscribe to it. When you subscribe, you don't get charged anything. It's an hourly rate. So whenever you start using it, only then you get charged. And we also have 1 month free trial. So if you just want to play with it, you're more than welcome, and we can refund your fees for the first 1 month. All right, so let's assume we prefer Oracle Linux. And the next step is selecting your database version. Well, I hope majority can select 19C already, but in case you have to use an older version, that's okay too. So you can select 11.2, Enterprise Edition, or Standard Edition, or any prior versions. And also, you can select the database release update or PSU that you want applied to your database home. And you also have a choice of GI release update, although we always recommend the latest one. And the grid infrastructure software will be always 19C, regardless of your database version selection. So that later, when you want to upgrade your database software to 19C, hopefully sooner rather than later, you don't have to worry about grid infrastructure software update. Next, based on the selection of the database version and the release update versions, we present you with a list of Oracle installation files that you will need to complete this deployment process. And so the deployment process includes installation and configuration of grid infrastructure and patching of grid infrastructure home, and also installation of database software and patching of the database software. But we do not distribute Oracle binaries. So we ask you to get those files from Oracle's website and upload them to your S3 bucket. And then when the deployment happens, it will just take those files from that S3 bucket. And in case you do not have access to Oracle support, because some of these files are require access to support, you can actually select at the previous step. You can select none for release updates, which is also okay, especially with the 19C. Although, of course, we recommend the latest patches, but if you don't have access to Oracle support at the moment and you just want to try it out, you can do this. So this way we can reduce it down to the list of files that are available from Oracle's main website under OTN license, so that you don't have to use support. All right, and here then you just provide the name of your bucket and the folder where those files are located. For now, I'll just enter demo/demo. Let me move to the next tab. Okay, so next you can set the host name for your that will be configured in the operating system. You can select the domain name. More importantly, you can select the instance size. So like Emil mentioned, there is a long list of various EC2 instance types and sizes that are supported. So you can select one from this long list. And we list only those that actually make sense for running Oracle database. And then you can also select the availability zone where this instance will be placed. So if you use, depending on your needs, this might be important selection. Okay, so next is an interesting part. This is where you configure your storage. So keep in mind that we allow you to use multiple EBS volumes. And that helps you with both with the capacity and more importantly with performance. So you get the aggregate performance of all those EBS volumes combined. And you can select how many EBS volumes and what size of those EBS volumes you want included in each of your disk groups. So these are the disk groups that we suggest by default, but of course you can customize the list. You can add additional disk groups or remove or rename them. And you can, more importantly, you can change size of the disks and a number of disks per disk group. So, in this example, we have 3 times 1000, which means for data disk group, you get 3000 gigabytes. And there is also a separate disk group for separate grid disk group where we have the OCR. You don't have to worry about that. That will be created automatically. And also the, like Emil mentioned, there is the type of volumes, EBS volumes that we use is general purpose SSD, which is much less expensive than provisioned IO, but it allows you to achieve same level of performance by just adding sufficient capacity. So effectively, you can max out the throughput, the storage throughput of the selected EC2 instance using these general purpose SSDs and have larger capacity and lower cost. So this is the benefit of combining multiple volumes using ASM disk groups. So you can use cheaper storage and have the same or even higher level of performance. Next. So we automate configuration of huge pages. As you probably know, huge pages are important for reducing CPU overhead, for managing memory. But because on AWS you have this flexibility of changing instance sizes. Well, when you change the size, also gets different size of memory, and you want to adjust your huge pages accordingly. So you don't want them to be set too high because then your system will not boot. You don't want to be set too low. And manually adjusting kernel parameters is fine, but just an extra step. So we automate the process for you. You can just set the percentage that you want to be allocated for your SGA, and we configure the corresponding amount of huge pages automatically. Network. So here you specify the ID of the VPC where you want this database server to be deployed. So in most cases, you probably already have a VPC configured, and you just want your database server to be deployed in that VPC. So on that, just provide the VPC ID here. But if you're creating just a sandbox environment and you're not, you just want to see how the database server works and you don't want to have any other resources on that VPC yet, you can just keep this blank and it will create a VPC for you. So it will just make it easier. And you can even assign public IP so that you can just connect through the internet without having to configure VPN access and stuff like that. So it's not recommended for production environments, but for just a sandbox environment, that might be okay. You can add custom DNS servers. By default, we use Amazon's provided Route 53 DNS, but you're free to add your own DNS servers if you have to use those. You can configure alerts. So if there's anything wrong with at the server level, you will receive email alerts. And so you can provide your email address or multiple addresses. And you can also allow it to send alerts directly to our support team. So in that case, we can react quicker, even if you missed the alert for whatever reason. And finally, you can add tags for just asset tracking purposes that will be attached to your EC2 instances and EBS volumes. And that's pretty much it. At this point, we just need to validate that the configuration is consistent. So we do that, and now it shows the screen message that everything is good and we are actually ready to launch SkyBase. Before you do that, I actually suggest that you save this configuration because you spend some time entering all those parameters. You probably don't want your work to go to waste. And if you need to deploy a similar, redeploy the same server, or you want to deploy another one in a similar configuration, you can reuse the parameters that you just entered. So you click download and we'll save the text file on your computer. And later you can upload it using this upload link in the top right corner. And then you can start from an existing configuration. So once we do that, we are officially ready to launch it. So we click launch, and it takes us straight to AWS console, and more specifically to CloudFormation Manager. So by this time, you need to have your AWS account ready, and basically you need to sign into your AWS account. And what you see here is that the launcher tool generated a CloudFormation template file, and this is the file. And you basically deploy this template in your EC2 account. So there are 2 more additional steps needed to make it happen. So click next, and this is where, well, first there's this AMI. It shows you the AMI ID that will be used. This is basically the AMI ID corresponding to the marketplace image in your target region. In most cases, you do not need to change it. And the SSH key. So this is the key that you already need to have configured in your account so that you can access your EC2 instance. If I used an existing VPC, it would also ask me to select subnet and security group, but because I left it blank, so it will just create an VPC for me, so it's not asking me for a subnet ID. Right, next, there are some more advanced parameters for CloudFormation that we are not interested in at this time, so we can just click next one more time. And it's basically ready to deploy the stack. So if I click Create Stack, it will start the process of creating the VMs, attaching the disks, and it will do software initialization. So it will configure the SkyBase software. It will install and patch grid infrastructure software. It will configure your ASM disk groups, and it will install and patch the database software. So in the end of the process, and I'm not going to do it now because it would take 30 minutes, but basically in the end of the process, you will have a fully functional database server with ASM disk groups already configured and ready for use. And what we do not do is we do not create a database, at least not yet. So so in most cases, you already have your data somewhere. So you can run a DBCA to create your database, just like on a regular database server, or you can restore. You can do import of data, or you can restore from RMAN backup. It is up to you. Or you can configure data guard replication and to move your data from an existing database server. So all those options are, pretty much all those standard mechanisms for moving data over to a new database server are still available to you, and you're free to choose whichever meets your objectives better. And one more thing I'd like to mention here is that you can see that because this is just standard CloudFormation functionality, it actually allows you to do cost estimates. So if you click here, you can see you can see the components and how much they will cost on a monthly basis. From EC2 perspective, and separately, let's go back to the launcher tool, go back to the OS selection. There's a link to the marketplace. So if you click here, it will take you to the marketplace page. And here you can also see pricing for our software. So there are basically two components to the pricing. It's the EC2 and EBS infrastructure that AWS will charge you for, and also our software fees that are listed here that are hourly or annual if you choose to, but in the beginning, I guess hourly is a more logical choice. And that is also charged through AWS, so you don't have to worry about procurement process with FlashGrid. So you can do, you can get everything built through AWS. And that's pretty much it. So once you click the create stack, in 30 minutes, you will have your database server up and running.
Thank you, Art. Thank you very much.
Oh, one more thing I actually like to add. So this is, as you can see here, on the product page, this is right now in preview mode. So SkyBase is a very new product, and in September we're planning to make an official general availability release. But you're more than welcome to actually use the preview version, and we actually will fully support it. And also, the configuration that I showed you is just the standard configuration that Emil mentioned, without using the local SSDs and without using the external database, external storage servers for extra capacity. So those, if you're interested in one of those more advanced configurations, please let us know, and we will help you with configuring those. The deployment process will be pretty much like the one I showed you, except you will start with a custom config file. So as we move to the general availability, we will be adding those, and they will be available right away from our website. But in the meantime, let us know if you are interested in those more advanced configurations. Thank you so much.
Thank you, Art. So this is Emil. Let me wrap up this session. There is our website, www.flashgrid.io, and general email, info@flashgrid.io. If you feel you need some help with sizing your Oracle server on AWS or using the provisioning tool that Art just showed you, please reach out to us, and we will be happy to schedule a call. So that ends this presentation. Please stand by for some announcements after we finish presenting. So thank you.